So if you did type it in, and I typed it in my list, I go to calculate one variable stats. Again, if only I know my Greek letters, I see x bar, 69.4. I see SX and I see sigma x. Which one am I wanting? Which one am I wanting? Why am I wanting sigma x and not SX?
Oh, because it's a sample, not a population.
Because we're dealing, SX is dealing with a sample, and we're talking about the population. And so again, if we just know our letters, we're good to go. So we want the sigma x, which was 7.63. Woo! Okay, so running low on time because Miss Compton got off track. Happens all the time. If we had time, we would make. No, it really would. I've been meaning to tell y'all that since last night. I just wanted to tell you. Since then, I made a dot plot. I did from 50 to 90. And then I made my dot plot. And if I wanted to try to put a bell curve on top of that terrible dot plot, it would look quite skewed. Yeah, that was just neat and quick. You could count by tens, 50, 60, 70, 80, 90. You do not even have to make the dot plot. It's just talking about how spread it is. Super spread. Okay, so let's use our random number generator and see if we can't. I'm going to pick a random number between 0 and 9 because we're dealing with, that's how we numbered our students, student 0 all the way up to student 9. So I'm doing a random integer. I didn't do rand. So I go to math, spell little prob, random integer between 0 and 9. And I typed that in wrong. Yay. Math, prob, random integer, 0 to 9. And it tells me 9. So let's say in the next thing, I am picking student 9 because my random integer thing told me to. Student 9 had a score of 62. Okay, if I do the same thing again, random integer, run it again, I get 6. Student 6 made a 65. Random integer, I do it again, I get 4, oddly enough, and I get a 72. Random integer, I do it again, I get 1, and that is 62 as well. Okay, so we decided to just take a sample. We had a population of 10, so why on God's green earth we need a sample from that small population? I don't know. We're really just trying to prove a point. But we randomly got our sample. We picked 4 students. What's wrong with our sample? Well, it is large. What else is wrong with our sample?
It's random, so I don't know.
Well, it is random, but aren't our scores all on the low end?
Yeah.
Yeah. But, okay, so let's roll with it. So it says the parameter of interest, obviously we're wanting to show the mean score. We're pretending that maybe our population was so large we couldn't calculate the mean, which we already did, P.S. It was 69.4. But it was so big, we want to get near that mean with our samples. So hopefully when we calculate this one's mean, it will be near 69.4. I think we're going to be sorely disappointed, but that is life. So if I type this into L2, so in L2 I'm putting 62, 65, 72, and 62. And I go and I do my stat, calculate one variable stats, but I don't want L1, I want L2. I'm really sad to find out the mean is 65.25. So we wanted 69.4, and sadly I got 65.25. Okay, what notation should I use for that? The mean of the sample what notation do I use for that? Is that a mu, a sigma? Yeah, it's an x bar. Okay, the standard deviation of the sample, what should I use for that? What letter? The Sx. So I'm just going to put S, but Sx is what I'm looking at on the screen. So no, I'm not picking 4.0. Yes, I am picking 4.7. I'm going to do 4.72. And then our sample size was how many? 4. Okay, so thank you. It then asked us to graph these on a dot plot, so we code really fast. And what does each dot on the dot plot represent? So we probably do want to consider that. So I'm going to do 60, 70, 80, 90, just because I'm lazy. And we got 62, 65, 72, another 62. And I could try to fit a terrible bell curve to that. What does each of those X's I put on my dot plot, what do they represent? Yeah, they represent a student score. Students, principal today, score. But again, you knew how to do that. You knew how to pick a sample from a population and how to run this. That's not the deal. The deal is, how does this go from doing a sample to making what we talked about yesterday, which is called a sampling distribution. So we're going to need to take a couple of samples. So we've got one sample here. We need to do a couple more samples. So I'm going to need some more random numbers. You got your random number generator up. Can you pull up your random number generator? You too. Someone else with a random number generator and fast at it. Math and Scholar Prob. And then rand it. And we're doing between 0 and 9. I need some random numbers. 9, 5, 0, 4. Okay, well 9504, student 9 made a 62, 5 made a 73, 0 made an 82, and 4 made a 72. So these scores are looking a different kind of skew. I wonder what their mean is and what that standard deviation is. Because they numbered them weird. They didn't do 1, 2 through 10. I think they were just trying to do the integer, like, be weird. Okay, what about my trial 2? What numbers are you picking? 9, 1, 5, 4. We have. Curious. Now, can that happen? Yeah. If you just calling out stuff, I don't know or care. It's still random. Hopefully one of those will leave us now.
That's a good number. I got 7039.
Oh, darn you, 9. 9 is 62. 0 is 82. 7 is 66. 3 is 58. Okay, so I'm quickly going to calculate. I'm going to call this one x2 bar. And I'm going to calculate its standard deviation as well. And I'm going to do x3 bar and its standard deviation. I might give it a tiny subscript as well so I can keep track of them. X4 bar, maybe even its standard deviation. If someone could do trial 2, I'll do trial 1. And if someone else could do trial 3, man, that would make our life so much easier.
I'll do trial 3.
Perfect. Okay, so I'm calculating my one variable stats. I typed in trial 1 into L3. So when I do my one variable stats, I get my x2 bar is 72.25. And my standard deviation is, zoom in on that, 72.25. And my standard deviation is 8.18. Does someone have trial 2? keep these on now because I already got trial 2.
Okay.
I got 67.25. And my standard deviation was 6.08. Surely someone has trial 3. Because if I can beat you to that, that's just sad.
I got 67 for X bar.
Okay.
And then 10.52 for standard deviation.
Okay, perfect. 5.2, right? I'm sorry, it's on the screen now. Okay, it says the parameter of interest is still the mean score in the population, which we already calculated. It was 69.4. What do you expect to be true when you calculate the statistics of the sampling distribution? What should happen?
The mean should be the same.
It should. We should have the mean of all our trials. Oh, that would help. We should have that the mean of all our trials matches the mean of the population. The mean of the population is represented with what letter?
U.
And then the mean of all our trials
X bar.
is all our little bitty X bars. So hopefully when we calculate the sum and figure out all our X bars, they had a notation for it yesterday. It was a good one.
And X bar.
They said, yeah, I like that because we're just summing all our different X bars. That's an ugly sum symbol. Sum
Wait, are we just adding
X
up?
bars.
So we have to divide by n.
Yeah. I was wondering if we're going to get there. So, and you're like, what on God's green earth do you mean by that, Ms. Compton? And it's fine if you don't know. So let's just go straight to the bottom of, can we make a dot plot? So let's make a dot plot. I'm going to do 60, 70, 80, 90 again. For our trial, our very first one on that front page, we got 65.25. So I'm going to put that one here. For our second trial, which we're calling our first trial, but the one at the top of this page, we got 72.25. I'm going to put that there. For our next one, we got 67.25. I'm going to put that here. And our last one, we got 67, so it's a little lower. Put that right in there. And all our dots are pretty concentrated. So we've graphed it. What does each dot in the dot plot represent?
The average is all the sample.
Okay, so it's the average of each sample. Each sample's score. So as long as we've recognized the fact that, hey, with this, which is called a sampling distribution, because we took a bunch of samples and we put them on the same graph, when we make our marks, like my X's, they're not actually standing in for the student scores, but rather the average of the samples of the student scores. Okay, so we've still got 3 blanks to fill in and we can stop rambling for today. We want to know the mean of the sampling distribution, the standard deviation of the sampling distribution, and the sample size. The sample size is actually not 10. It would be 4 because we did 4 trials. How many trials did we do? 4. So the sample size is 4.
And the mean was 67.94.
It better be. Mean of the sampling distribution is 67.94.
Yeah.
So we're a little sad. Why are we sad?
It's lower than the actual.
We're sad because we wanted 69.4. And then the standard deviation of the sampling distribution is,
Sigma, or is that? What's that sigma, right?
it's going to be, we're going to take the sigma, but we're going to divide it by the square root of n. And you're like, where the crap did you get that from? And I swear I'll show you that tomorrow. Just roll with it for now.
Wait, sigma over square root of n?
Yeah, n being the number of trials.
So then that would be
So square root of 4 is 2. So sigma divided by 2.
3.
Yeah. I'm good with that.
Wait, equals blank over 2? Wait, what?
What was the standard deviation? Tell me what the sigma was. 2 point something. And he got that by going into another L, like L5, and typing in the X1 bar, the X2 bar, the X3 bar, the X4 bar, and then making it one-to-one variable stats. We'll come back to how to do this tomorrow. I'll start recording now.